Hello, welcome to the first class on circle theorem. We'll be starting with theorem 1. Theorem 1 states that the angle subtended by an arc at the center is twice the angle subtended at any point on the circumference. Now we have arc AB, this is an arc. So we have arc AB. Arc AB subtends an angle at the circumference, which is point P. Then that same arc subtends another angle at the center. So what this theorem is saying is that if an arc subtends an angle both at the circumference and at the center, to get the angle at the center, you would multiply 2 by the angle that it's also subtend at the circumference. So an angle subtended by an arc, the angle subtended by an arc at the center, to get it, it is 2 times the angle it subtends at any point on the circumference. So let us prove theorem 1 on the board. Now we want to show that AOB equals to 2 times APB, that is, angle at the center is 2 times 1 at any part of the circumference. To do that, let's have our circle back. Now, let the arc subtend an angle at the circumference, arc AB, and as well subtend another angle at the center. Now that center O, of course. Now let it be P, and let it be center O. Now let's assume that we divide this angle P, and then it meets at the center and comes out at Q. Let's see what we'll have. So make this angle, give the individual angles, give its variables, right, to differentiate them. Let here be x1, let here be x2, and then we could say this other side, let's use y1, then let's use y2. Now looking at this, we would observe that this line from this center to this place is a radius, because any line drawn from the center to touch the circumference is a radius, and from the center to touch the circumference is another radius. So we could conclude that this line and this line, they are the same because they have the same length, they are both radius. Then if two sides of a triangle, if they are both the same, then the triangle itself is an isosceles triangle. That means that if I have something like this where they are both the same, that is, this line is equal to this line, then the base angles will be the same. We would have that from here. We could say that OP, line OP is equals to line OA. This is center OA, then they are both radius, right? They are radii. So you would also see that these base angles, they are the same. I just said that it's an isosceles triangle. So if they are an isosceles triangle, these base angles, they are the same. So we would have that x1 is equals to x2 because base angles of isosceles triangles, they are the same. Base angles of isosceles triangle, they are the same. Now, if I know that the base angles of isosceles triangle, they are the same, then I'm noticing something else here. I notice that this angle that is here, that's angle AOQ. I can get it. And how I can get it is the sum of the two interior angles of this triangle is the same as the exterior angle of that triangle. So the sum of x1 and x2 is the same as this exterior angle that is here. So we would have that, I can write that AOQ is equals to the sum of x1 and x2 to give us this exterior angle equals to x1 plus x2. Then we'd say that exterior angle of triangle AOP, right? So this exterior angle, we've gotten it. Now, but we know that x1 and x2 is the same thing. Then I could remove this x2 to represent it with x1 since they are both the same. So if I could say that AOQ is equals to what? 2x1, because if I remove this, make it x1, then I have 2x1 for AOQ. Now, if you look at these two triangles, they are the same. So whatever that's happening to this will also happen to this. Then BOQ will also be what? 2 times y1. So that would be what? BOQ will also be what? 2 times y1, because the same thing that we did here will be the same thing that we're playing out in this other triangle. So we know that BOQ to be what? 2y1. Then moving on from there, let's assume we want to calculate AOB, that is this total angle at the center here. So AOB, now to do that, then we need to know this angle and this angle, these two angles, then sum them together. So for this particular one, this one is AOQ, this place is AOQ. That means we are adding AOQ plus this place is BOQ. Now if you check from the board, we already know AOQ, we already know BOQ, and then we know them as, first we know this as 2x1 then plus 2y1, right? So if we factorize, we have 2 into x1 plus y1. Then so therefore AOB is equals to 2. Now if you look at x1 plus y1 is this two angle that is here. So if we are adding these two angles, it gives us the angle P. So we could say APB. So it will be x1 plus y1 APB. Now we've just shown that angle at the center angle AOB is the same as what? Angle 2 times angle at any part of the circumference. So we've just shown that AOB is equals to 2APB.